in this video, we are going to be talking about significant figures. Every single non-zero number is significant. It starts to get a little bit more difficult when we're asked, are these zeros significant? I'm going to start with the easiest rule, in my opinion, is that any zero sandwiched between non-zero numbers is significant. In our first example, we have 1, 2, 3, 4 sig figs. These two zeros are in between 3 and 9, it makes them significant. In our next example, we have 1, 2, 3, 4, 5 significant figures. And once again, our zeros are sandwiched in between non-zero numbers. That makes them significant. The next rule about sig figs are leading zeros. All leading zeros are insignificant. So we are not going to start counting our significant figures until we hit a non-zero number. So kind of scan your number, and then once you hit your first non-zero number, that's when we can start counting sig figs. So these zeros are leading zeros. They are not significant. And now we just are left with 2 sig figs. Same thing in this case. All of these zeros are insignificant. We're not going to start counting until we hit our very first non-zero number. Leading zeros, insignificant. Here we have 1, 2, 3 sig figs. Our next rule is about trailing zeros. Trailing zeros are any zeros that don't have a whole number after it, okay? So in this case, we have these 2 zeros, and they're not sandwiched between any 2 non-zero numbers, but our trailing zeros are always significant if there's a decimal point anywhere in our number. We have 1, 2, 3, 4, 5, 6. We have 6 significant figures here. So this zero is significant. Why? Because it's sandwiched in between 2 non-zero numbers. Those trailing zeros are significant because there's a decimal point. In our next example, we don't start counting sig figs until we hit our first non-zero number. So these 3 are not significant. We have 9, 8, and 0, so that's 3 significant figures. That last 0 is significant because we have a decimal point. So in this case, we have 3 significant figures. Trailing zeros are insignificant when we don't have a decimal point telling us it's significant. So for 50, we only have 1 significant figure. This 0, completely insignificant. We don't have a decimal point there. We don't have it sandwiched in between 2 non-zero numbers. We don't really look at it, okay? In our next example, 1, 2, we only have 2 significant figures. These zeros, I have no decimal point anywhere in this number to indicate that they're significant in any way. If we look at the same numbers, but we add a decimal point, that instantly makes any zeros there significant, okay? There's a decimal point. All of our zeros are significant unless they are leading zeros. So in this case, we have 1, 2, 3. We have 3 sig figs. In our next example, we have 1, 2, 3, 4, 5. We have 5 significant figures. When we are actually doing math equations, we have 2 different rules for significant figures. When using multiplication or division, our answer has to have the amount of sig figs as the least amount of sig figs that we had. In this first example, 13.7 is 3 significant figures. 2.5 is 2 significant figures. This means that our answer has to have 2 sig figs. When you plug this into a calculator, you are going to get 34.25. However, our answer is just 34. This is because our answer has to have the amount of sig figs as the least amount that we were working with before. So our answer must be only 2 sig figs. In this next example, our first number has 4 significant figures. Again, this trailing 0 is significant because we have a decimal point. Our next number only has 3 sig figs. So when we divide them, our answer can only have 3 sig figs. When I plug this into a calculator, I get 11.5966. However, my answer must only have 3 sig figs, so I'm going to round to 11.6. With addition and subtraction, we don't really care about the amount of significant figures. We more so care about the digits after our decimal point. In this first number, we only have 1 number after a decimal point. Our next one has 3, and our final one has 2. So whatever my answer is, it can only have one digit after the decimal point. So when I plug this into my calculator, I get 35.083. But my answer can only be rounded to the 10th place. So my answer is going to be 35.1. In our next example, we have two digits here and we have one digit here, which again means my answer can only have one digit after my decimal point. When we plug this into a calculator, we get 58.66. But this has to be rounded to give us only one digit after our decimal point, which would give us 58.7. When dealing with a question that has both multiplication or division and addition or subtraction, you need to be very aware of the sig figs in every single step, but you cannot round until the end. So you really need to track it as you go. And you will only be asked a question like this maybe on your first exam about sig figs. And if you have a teacher who's not the nicest, possibly on a cumulative final. So if we plug in this addition problem first, so whatever is in our parentheses, we would get 12.34. Our actual answer, so if we were just asked, what is the amount of sig figs, or what is our correct answer when we are doing 5.64 plus 6.7, our answer would be 12.3. This is now 3 sig figs. And then when we multiply this by 3.489, well, this number has 4 sig figs. After completing this, our answer can only have 3 sig figs. When I plug this entire thing into my calculator, I'm going to get 43.054 and then some other digits. My final answer is going to be 43.1. If you were to just round as you go, we would get 3.489 times 12.3. So if you were to think, oh, this guy only has one digit after the decimal point, so let me just round it here and then do it, my answer here would actually be 42.9 something, something, something. In this case, you see that you have 3 sig figs here and 4 sig figs here. Our answer would have to be 3 sig figs. These two are completely different numbers. If you had this question on an exam, you will likely have both of these numbers as an answer choice. You need to know that this is your correct answer because you cannot round until the end. This is it for our lesson on significant figures. I hope you all enjoyed, and I will see you in the next video.